Hello world! Welcome back to another picoGym workout exercise video. In this video, we'll be walking through the cryptography challenge rsa-pop-quiz. Let's get into it. Now this is already solved because for some reason when I went to record it on OBS, it was recording, but it wasn't actually recording. It was kind of like stuck or something. It was weird, which is unfortunate because this is a pretty long one. So I'm re-recording it now and hopefully it'll be even better than it was before. So let's get into it. Class, take your seats. It's prime time for a quiz. All right, they give us a netcat portal to connect into. So let's go ahead and do that and see what we're dealing with. And blah, da, 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 da. Basically it's saying that we're taking a quiz and it gives us a new problem. Q and P produce the following N. But first it asks, is this possible and feasible? So we're gonna say yes, because we know that N is just P times Q. So time to show me what you got. And if we do this on let's do this on a calculator. We do 60413 times 76753 like so. We're gonna get this. So we'll just type that in, 636 878 989. And there we go, we got it right. And then we move on to the next problem, same format. It shows us certain values and to produce the following, and it asks, is this possible and feasible to produce that number, which in this case it's Q, and we're gonna say yes, because all Q is N divided by P. Assuming that P is a factor of N in this case, and it is, we can easily test that by just doing this value divided by 54269 like so. And then we get 93,089 as our answer. Now we move on to the next one and you can see it's the same format. The issue with this whole thing is that it times after a certain period of time and some of these take a little bit longer to calculate. So we kind of need a way to kind of save our results as well as track our progress. And we can do that using Pwn tools and writing a script to kind of automate this for us. That being said, I already have a script prepared here. Well, there's nothing in it yet, but we can start off by doing from Pwn import star like so. And then we're gonna do with context.quiet. That way we don't get all the extra Pwn tools output that comes, whenever you run a script using Pwn tools. And then we're gonna define our remote socket. And let me go ahead and just copy it from here. Grab this portion. Don't need that double quote there. And we need one here. And there we go. Now we have our remote port set up. Let's go ahead and test that to make sure it's working. And we'll just kind of print out the first prompt or welcome and all that just to prove the concept. And if we take a look at the prompt format, we can see that our first entry is going to be after this closing parenthesis and colon. So we'll use that as our parser here to receive until. And make sure to put the B in front of it to designate as a byte array, because in Python 3 you need to do that. It's not implicit type differentiation like it was in Python 2. And then we're gonna just do .decode to turn it into a string, because if we don't do that, then it's going to print out all the escape characters as /n and /t. It's going to print all those out rather than just have them formatted that way. So if this works, we should see this first welcome message and prompt here up until this point right here. So let's go ahead and run that. And it worked. Okay, so now we can start actually solving the problem. So now we just need to do print s.sendLine and with a y, right? Because we're answering the first question. And then we're gonna do another s.receiveUntil right here. And we'll do it up until the colon and the space because that's where we're inputting our next value in. So we wanna get this portion up until here and then put in our next answer. So I also forgot to put a P at the beginning there. All right. And now we can actually solve it. So let's do Q equals 60413, P equals 76753. And then we're gonna do N equals P times Q. And then just to track our progress to make sure we're getting the correct values out, we'll do print in case we need to debug and whatnot, in equals, and then we'll do plus strn, because remember, we need to convert it to a string in order to print it to the line. And then we need to do s.sendLine strn dot encode, because that'll convert it to a byte array. And then to make sure that we got it right, we're going to print the next prompt, because if we get it right, the next prompt will print. If we don't get it right, it'll probably exit out. So that should be good for the first part. So let's go ahead and run that. And indeed it worked. We get the next problem. We can see what our n ended up being up here, and it matches what we got over here since it's the same challenge. And now we're calculating q. Okay, so now that we kind of have this process down, we can maximize this so we can see it better. And we're gonna go ahead and jump straight into solving for q. So we'll copy what we had before, and we know we're sending y and then the prompt, and we know that n is going to be equal to, well, here, p, and we'll make this n, we'll make this q. Q is equal to n floor divide p. Now let's go ahead and grab these values and replace them here. And then we want to make sure to change our values in our output to q. And then of course print the next prompt to make sure that we got it right. Now let's try running it. And there we go, we get our next one. So we need to produce the following from E and N. We need to get P and Q. Now, this is a scenario where it's going to be no. And the reason I know this is you can check what N is going to be inside of either SageMath or FactorDB. SageMath is going to be a little more thorough because it's actually going to be able to factor it for you, whereas FactorDB is just going to have it stored in there. If there's factors for N, it's going to have those stored from when it calculated it beforehand. So it's just a database versus an actual calculation. We're gonna go ahead and just run SageMath on it, and you can just do factor, and then I'll have to right click, paste that in. Now I'm gonna go ahead and close this because I know it's gonna be a no. So we're just gonna copy this line right here. And we're gonna recopy this line. Change this to a no. And the reason I canceled out of SageMath so quickly there is because it would have gone on forever because there's no factors for N in that case. But you can see that here. So we put in outstanding move, that means we got it right. And now we're calculating the totient. Now I know this one's gonna be a yes, so I'm gonna go ahead and copy one of our previous answer blocks here, answer code blocks. And we're gonna go ahead and calculate the totient. So all we need is Q, or P, and Q, and T. So that's 12611 for P, although it doesn't really matter, 66347. And then totient is just gonna be P minus Q times Q, or sorry, P minus 1 times Q minus 1. Okay, then we're just gonna say T here, and T here. And then of course, print the next section, like so. And hopefully we get that right. So let's run that. And we did, because now it's asking us to calculate the ciphertext. So for this one will also be a yes. So we'll go ahead and copy what we had before. I'll go ahead and make sure to copy the prompt this time, that way we can get the next one without me having to recopy it each time. And we're given the plain text, so we'll call that PT, and that's this value right here. And then we're given E and N. E is 3, N is this long thing right here. All right. Go ahead and replace this with this, and this, and this. All right, now we just need to calculate the ciphertext. So CT is going to simply be the plain text raised to the E modulo N. And the PAL function allows you to do modulos if you add the third parameter in. If you don't add the third parameter in, it'll just do the first value raised to the second value. So that should be our ciphertext. So let's go ahead and run that. And we can see that it worked right here. There's our ciphertext. And now it's asking us to calculate the plaintext. Now I know for a fact that this one is also going to be no, so we'll come back up here. Just kind of copy this and paste that in there. And the reason why I know this is going to be a no is because n is not factorable here. So if we take n and we try to factor it in Sage again, like we did last time, it'll just run on forever because there's no factors. So we'll cancel out of that and we'll go ahead and run for the next section. And now we're going to calculate D. Now this one will be a yes. So I'll go ahead and grab one of our previous code blocks for yes. And we're gonna have P as this and Q as that. And then E is going to be that. And we're going to be calculating D. All right, so to calculate D, we first need to calculate the totient again, given the values that we have here. So we just need to do T equals P minus 1 times Q minus 1, like so. And then D is simply going to be the inverse of E, which is e to the negative 1, mod the totient. And that should be our answer. So let me go ahead and copy that so that we can check to make sure that we got that right. And we'll run that. We got an error. Oh, I forgot to put POW in front of this, that's why. Okay, there we go, that should fix our error. Let's go ahead and refresh that. There we go. Okay, little boo-boo there, but nothing to worry about. So now we're going to be calculating the plaintext, and this one will be a yes as well. So I'll come back up here and grab one of our shorter ones. And make sure to get this. I'm pretty sure this is the last one too. So instead of printing until the next prompt, we're just gonna do a receive all. I think receive will work as well, but it's whatever you want to do there. Okay, so we're given P. All right, so we'll grab that. And then we're also given the ciphertext, of course. Okay, and then we're also given E. And we are given N as well. And then we're going to be printing out the plain text. So I'll go ahead and do that. All right, now that we're all set up, let's go ahead and start calculating stuff. Okay, to calculate the plain text, we need to take the ciphertext, raise it to D mod N. If you remember earlier when we calculated the ciphertext, we took the plain text, raised it to the E, and modded in. So it's just reversed. So let's go ahead and calculate Q since we don't have that. And Q is equal to N or divide P. And then we're going to calculate the totient, which is T equals P minus 1 times Q minus 1, like so. And then we have to calculate D, which is power of E to the negative 1 mod T. And then our plain text is going to be power of the ciphertext raised to the D mod N. Okay, and that should be right. So let's go ahead and save that and let's run it. Did I accidentally put an extra character somewhere? Oh, there's a backslash there. Okay, there we go. That'll fix it. All right, let's rerun that. Let's get a fresh slate going here. All right, look at it go. Okay, so it does appear that we got it right. There's our plain text. If you convert the last plain text to a hex number, then ASCII, you'll find what you need. Sounds simple enough. Oh, where did that 5 come from? All right, so now that we know that, what we can do is we can do flag equals, and we essentially need to convert it to hex and then to ASCII. So what we want to do is bytes.fromHex, and then convert our plain text, which is currently an integer, to a hexadecimal number. Okay, and then we want to make sure to take off the first couple bytes, because if we do hex on our number, it's going to append a 06 to the beginning of the hex string. And so this will take off that 0x so that we just have this string, because once we have that, then we can just run .decode on it to get the plain text ASCII. And then all we have to do at the end is print the flag, and we should be good to go. And there's our flag. Wait, that's illegal. So you're gonna copy that, of course, and we're gonna pretend like I didn't solve this yet, and paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.